Hi everyone, this is Sultan, and in this video I'll show you how you can use Keil Microvision along with assembly language, and I'll show you how you can debug the code you write and check the results. Alright, so let's get started. So initially when you open Keil Microvision, this is what you'll be looking at. Alright, so what you need to do is first go to projects and create a new project. So you can create a project here. Let me just name it new project. And now here I need to search for a device. So the device I'll be using is AT89C51ED2. Right, so this is basically a high-speed microcontroller that I'll be using. So let me just click on OK. Now when this one comes, you'll only need to click on yes if you're using C program, but since I'll be using assembly language, I'll just click on no. Okay, now you can see there is target 1 and there is source group 1. So first let me just create a new file and let me just save it using Control S. So this is my code file, so code 1, and remember to name it with an extension .asm because you're using assembly language. So let me just save it, and once it's saved, right click on source group 1 and click on add existing files to group source group 1. So that will allow you to add the file you just created. So just go to file type and choose ASM, and here you will find your file. Click on it and click on add and close. So now if you open source group, you'll see this is added. Alright, now let me just add some codes here. So let's say I want to do addition in assembly. So addition, okay, so I'll just first define values. So MOVA, 21 hash 21H. Don't forget to give that hash because without that there will be an error, so make sure to use hash since it's assembly language. So use B comma hash 10H. Okay, now to add, I'll just use the add function, add A comma B. So this will just add both of them and temporarily store it. So this will add both of them and temporarily store it in A. So now let me just store the value of A into a memory location. Move 40H A. There you go. Now the added value is stored in A. Now let me just do a subtraction. So now the value of A has been changed here, so I need to define the value of A again. So let me just define move A. Let's use the same value, and B was already defined and it did not change. Okay, you can see, so I can still use the same B. So here I can directly just use the formula for subtraction where it is SU_B, and I'll just write A comma B. This means B is being subtracted from A and the value will be stored into A. Now I'll just place it into the next memory location. So that's 41H comma A. Okay, so now let's do some multiplication. So now again, since the value of A was changed, I'll have to define the value of A again. So that's A comma hash 21H, and I already have the value of B earlier which did not change. So now I'll just directly use the multiplication function, which is MUL, and write AB. Okay, so this will multiply A with B. Now The problem here is that this will turn into a 16 bit value. So in this case, what will happen is it's going to be converted into two different values to store in the memory in hexadecimal. Alright, so here what I have to do is I'll need to save it in two parts. So I'll just move 42H into A, and I'll move 43H into B. So basically the data, both of them will be temporarily stored in A and B by dividing it into 8-bit each, and then now I'm moving them into the memory into two memory locations. Alright, so the results are stored in that way for multiplication. Now let me do a division. Okay, D-I-V-I-S-I-O-N, division. So in the previous cases only A changed but B did not, but here you can see B changed in both cases. So now I'll have to define both of them again. So let me just define MOV A comma hash 21H and MOV B comma hash 10H. So now you can see I've defined both of them. Now to apply division, I'll just need to use div AB. Okay, so this means A is being divided by B. Now here in division there are two values generated. One is the result, one is the remainder. Okay, so again you have to store it in two parts. So I'll just store the value of the result in one location, 44H A. So basically the first letter here is where the result is stored, so I'm now moving it into the memory. And now for the second part, which is the remainder, I'm just gonna store it in 45H from B. Okay, so that's how easily you can do division. Now let me just do increment. So basically I need to define a value again, so I'll just define move A comma 21H, and I didn't put a hash there. Remember, you have to use hash when you define a value. Now if I just use INC A, this will be incremented, and I need to move it into the memory. So I'll just use 46H A. And in the same way, if I want to do decrement, the process is the same. Just so easy. These are basic assembly language, so no need to complicate yourself with it. I'll just define a hash 21H, and I'll just write DEC and choose A. Now I'll just store the result of A in a memory location. So let's just keep it up to that for now. Now let me just use the end function, which defines the end of the formula. So let me just save it. Okay, so now I'll just click on translate. So you can see translate means that it will check if there is any errors. There are no errors, and if I click on build, it will build the formula. Now if I go to project, you'll see there is this called option for target 1. So click on that. Here you need to set up the timer for the device and the target. So usually it's 11.0459. okay, next you can check the device. The device is still the same. You go to output, remember to create a hex file. Next you just move on to the debug section. You see there are two columns here. If you use this area, you can use it for an emulator. In this video I'll just show you for the simulator. That's what I'm using. Okay, now this option, you see it says run to main. This is only used for C programming. Since I'm using assembly, I don't need that. I'll just uncheck that and I'll click on OK. Okay, so I missed a small part here. Okay, so now I'll just translate it again, no errors, build. Okay, now since this is an IDE where I'm using assembly, so to see the results properly I'll just use debug. I'll just click on debug. Now you can see all the code is lined up over here. Here on top you'll see there is this two icons. One says step, another says step over. So if I click on step, it's just gonna read the line where these arrows are. Okay, so let me just click on that. You'll see the green color, and when the system reads the line, you'll see over here that it's taken A for the value 21. Now let me click on step again, and now it took the value of B as 10. Now in this line there is add. If I click on step now, it's gonna add the values. So let me click on step, and there you go. You see the values were added and stored in A. Okay, now I'll just move it into the memory. So if I click on this, and there you go. So now the value is stored in memory. Now for the subtraction, let me do the same thing. I'll click on step, and it took the value 21 for A, and I don't have to define B again as B did not change earlier. You can see B is still 10. Now if I click on step, the subtraction has been performed, and you see the value of the result is stored in A. Now I'll just store it in the memory. Now it's time for multiplication. Again, you see the value of A has changed, so I have to define the value of A again. Now if I click on step, you'll see the value of A has been updated. Now I'm on the step for multiplication. If I click on step, it multiplied, and you see it, whatever the result came, it converted into hexadecimal and stored them in A and B. Alright, because when you multiply 21H and 10H, they become a 16-bit number. So in this location you can only store an 8-bit number, so they converted, and now they are stored in both A and B. So now I'll have to store them separately in the memory. So first I'll store A and then B. So I'll click on step. Now A is stored. I'll click on step again, and B is stored. Now for division is the same procedure, but you see in the previous step A and B both has changed. A has 10, B has 2. So I'll just define them again. So step on A became 21. Step on B became 10. Now I'll divide A and B. So if I click on step, they have been divided. Now the fact is here in division the result is here and the remainder is here. The result is stored in A and the remainder is stored in B. So in this case 2 is the result with a remainder of 1. Now I'll store them in the memory, A and B. So let's go, and there you go, they're stored. Now for increment, it means that the value is increasing. Now before I explain increment, let me answer one of your questions that might pop up. You see here I'm saying that I'm storing it in this memory location, but how do I know it's being stored there? Well, you can actually check that. Below you see there's the disabled portion called memory. Click on that, and on the address just type in as I show you. Click on D:, then write 40H and press enter. And here you can see all those values were stored in the memory. The first one was addition, result was 31, and it's stored here. The second one was a subtraction, result was 11, it's stored here. Third one was a multiplication where two values were stored, one was 10 and another was 2. And for the division, the result was 2 and the remainder was 1. Now we will see real time for the increment. Okay, so let's see. If I click on step, it's reading the value of A as 21. I don't need to rewrite B, as increment is for this single value only. So I'm using the increment function. Let me click on step, and you can see the increment changed to 22. Okay, so it changed A's value from 21 to 22, and I'll store it in the memory. You see, until it reads this line, it's not stored in the memory. You can see there's nothing in the memory. So now if I click on step, you'll see that 22 was added to the memory. Okay, same goes for decrement. I'll just rewrite the value of A into 21 and then use the decrement function to decrease it from 21 to 20, and then I'll store it in the memory. and you'll see it's stored in the memory. So that's it. Now in debug mode, I don't need to end this. I'll just click on debug, and there you go. So I've successfully used assembly codes and checked if it's applied properly, and I also showed you how you can check if it's stored in the memory. So that's the very basics. There are many more you need to learn when you use this, because this software is very useful in creating codes for peripherals and actively using peripherals. Alright, so that's it for this video. I'll see you in one of my future tutorial videos. Take care.